Welcome to our presentation, Wikidata, a magic portal for Siegfried and Roy, towards a resolution for open registries and file format identification. Featuring myself, Kat Thornton, Ewan Cochran, and Richard Lehane. And of course, Siegfried. Now, the collaboration here was between the four of us, and of course Siegfried, and it began in November 2019 to January 2020. And the main bulk of the project ran from then until October 2020. We're still touching base frequently to discuss enhancements and the future of the project. We met from across New Zealand, Olympia, Vienna, and Ontario for myself at the time. And we could really only make this work with the tools we had like Google Docs, Google Meet, and GitHub. We did monthly sprint review and check-in, demos, testing, and a lot of topics to resolve. I logged 340 development hours, and there were at least another 10 to 40 across all of us spent on project management, plus hours given up by everyone else, trying to engage with the work. It provided enough time and level of dedicated freedom of thinking required to shape this first iteration effort. We will talk about the development aspects of this project shortly, but first Kat is going to talk about Wikidata.
Many of you may be familiar with the different language versions of Wikipedia, but the Wikipedias are really just one project of the Wikimedia Foundation. There's everything from a crowdsourced dictionary, Wiktionary, Wikibooks, a collection of collaboratively written books, all the way to Wikidata, a knowledge base of structured data that anyone can edit. This knowledge base is machine-readable, linked open data. It's editable by anyone with access to the internet. It's designed to support both human and algorithmic curation. And what I mean by that is that human users can edit via the web interface, and it's also possible to set up programs to programmatically edit via the API. And it's a fully versioned wiki, meaning that all of the edit history is captured and accessible just like you would be used to in any of the Wikipedias. Wikibase is the software that is used by Wikidata that lets us store, manage, and access structured data. Because Wikibase is free software, anyone can download Wikibase and use it to create a knowledge base of their own that you can populate with any data that you would like, including subsets of Wikidata, if that is helpful to your project. Many of you may be familiar with TRID. It is a utility designed to identify file types from their binary signatures. As part of Yale University Library's EASY Emulation as a Service Infrastructure program of work, Ewan Cochran contacted Marco Pontello, who created TRID, to ask permission to do an import of data from TRID into Wikidata. Marco agreed and approved the proposed structure that Kat suggested for the Wikidata statements, including references. And we want to say a big thank you to Marco for all of the work that went into assembling all of these file format identification patterns for so many different file formats. So over the course of 2021, we added more than 9,000 file formats sourced from TRID to Wikidata. And this import increased the number of file format items in Wikidata from around 4,500 to more than 13,000. Here is an example of what a file format item looks like in Wikidata. All of them have a unique numeric identifier, or QID, which you'll see next to the label for the Feather file format. And I want to draw your attention specifically to this property here for the file format identification pattern. And this is where the data that Siegfried and Roy use is pulling from Wikidata. So here we have the value of the identification pattern and 3 required qualifiers. for encoding, the number of bytes of the offset, and whether that offset is relative to the beginning of the file or the end of the file. And you'll see there's also room for a reference. Each statement in Wikidata actually has room for a reference, and we can see here the URL from which this information was sourced. A quick note on data quality in Wikidata. Wikidata is designed to support multiple data models, even if they are contrasting. And there is a system of constraint warnings and constraint violation reports in use in Wikidata. But these are warnings. They're not enforced. The system will allow users to publish data that is in violation of one of the constraint warnings. We're still in the early days of tool building. Later this month, it will be Wikidata's 9th birthday, so Wikidata is still a relatively young project. But in September of 2021, there was a week-long series of events called the Wikidata Data Quality Days. And if you're interested, you might want to do a web search to find out about the events of that week. There are recordings available, slide decks available, and it's a whole week-long worth of discussions about what's going on with data quality in Wikidata. It's an area of a lot of interest. But right now, there are still contrasting data models for some domains in Wikidata. So one of the ways that data models are shared on Wikidata is through the use of the set of schemas that are written in the shape expressions language, SHEX. SHEX is a formal modeling and validation language for RDF graphs, and it can be used to validate entity data from Wikidata. So there is a relatively new namespace in Wikidata for schemas, and this is namespace E. And this is a place where you can publish data models and also gain consensus so that more and more people are trending toward using the same data model per domain. For example, here is a SHEX schema for file formats with identification patterns. This is schema E237, and you can find this on Wikidata in the schema namespace. And so here you'll find all of the properties, all of the qualifiers, and the reference structure that is expected on a file format item that has a file format identification property, as we showed in the Feather file format example. Another way that you can contribute data in a more guided way is by using the tool wikidp.org. So this site is a portal that sits on top of Wikidata, and it offers guided curation where you can navigate to a file format that does not yet have a file format identification pattern, and then you can use a schema over here to guide your curation. So it will show you what properties and what qualifiers are required, and it will only let you save values that adhere to the data type requirements of Wikidata itself.
Siegfried meant extending both Roy, the component of it which manages signatures, and Siegfried itself, the identification component, so mostly how it returns results. Roy deals with harvest and building, so it harvests data from Wikidata, and it uses that data to build a compiled signature file, which Siegfried can use to return results. Siegfried focuses on identification, and it contains all the information about the different algorithms which it can use to perform its pattern matching on different types of binary object. And Siegfried returns data in the form of format identification results. From Wikidata, that would be a QID. But most of the work would be in extending Roy. We would add a new Wikidata component. We would connect to Wikidata to download signatures. We save those signatures to be compiled locally. We use Wikidata information to create a compiled data set which contains the signature, labels about the file, labels for the file format, the identifiers, plus any other metadata that we're interested in. We enable Siegfried to read that back, and we enable Siegfried to use that as metadata to return to you. The sparkle we use to return this information looks like this. It's very easily extensible. I invite you to go and have a look and try it out on the Wikidata query service too. If we wanted to extend it to include software that can read the format described by this URI, we would add this line to that sparkle, and then we would be able to ask Siegfried to return a result that looks like this. This is actually part of a demo that I did for the team. We'll demo where we landed shortly, but first, reflections on the project. It was hard work learning a new code base. Despite strong background in programming and extensive background in signature development, a lot of terminology and ideas felt very different. There's still lots to learn for me around Siegfried's implementation. It was eye-opening, but a really cool implementation, and I learned a lot. There's a lot of data in Wikidata to chase, which we need many of Kat's techniques for, and lots of community effort. The collaboration was fun. Siegfried is super extensible. It was nice imagining new possibilities and trying things out. I really started to think about how Siegfried and different data outputs could be combined, mixed, and remixed. I enjoyed the collaboration. It was great working with everyone. Ewan's direction, Kat's knowledge, and Richard's skills. It's great to be left with the ability to help maintain Siegfried moving forward. Wikidata and Wikibases are cool. Now, they're not new to me because of other projects that I actually do and I'm involved with, but it is a new community to me, and with different tooling than I am used to. I gain new perspective on how it could be sliced into many different domains and used by them. Okay, time for the demo. We're going to look at the project output, plus a little bit of a sneak peek about where we're going later in the year. There are a handful of things that we're going to look at when it comes to the Siegfried Wikidata integration. We will start with Siegfried's partner tool, Roy, and how it harvests information from Wikidata to then turn into a signature file that can then be consumed by Siegfried. Roy harvests with a Wikidata flag. It currently takes about 3 minutes 50 seconds. This is because there is a lot of data on Wikidata about file formats, and as of a recent development, we augment that with information available from the Wikimedia API that describes the history of each of those records. The result is this Sparkle JSON report. We have a description of the fields for which we have asked information for, and we have data for each of those fields for each of the file formats in Wikidata. Now, this report is currently sitting at around 600,000 lines. You have at the top of the file, you have the JSON the Sparkle JSON, and at the bottom of the file, you have the provenance field. Within there, for each record downloaded from Wikidata, for each QID, we have information about all the last activities on each of those records. So we can see here, we have a title, a QID, we have a permalink for the record as it was today when I downloaded this, and we can see the last 3 people to have edited this record. Once we have this stored locally in Siegfried's home folder, we can then use Roy builds Wikidata to build a compiled signature file, which Siegfried can then consume. Here we also use the flag no pronoun, just so that we can see the Wikidata only results. And we use Wikidata debug. Wikidata debug turns on linting, which provides us error messages or warning messages about our data that allows us to improve what is in the service. So we can see the report that is generated by the build process here. We have 9,000 records with signatures, and we can see the linting messages here. Using this linting information, everyone in this room is able to log into Wikidata today, create an account, and start improving the quality of the signatures on the service so that next time someone downloads their signature file, they are able to benefit from your work. Once we have a compiled signature file, Siegfried can consume that to identify files. I have a small sample set here, and I can run Siegfried, pipe it through less to show you the results. Siegfried's results look familiar to anyone who might already be using Siegfried. The Wikidata changes allow us to see that we have used the Wikidata namespace, which means the Wikidata identifier was used. IDs from Wikidata are called QIDs, and here we have a QID for Windows Bitmap version 2. Here we have the Wikidata URI if we want to access that right now. We don't have a MIME type for this record, so that is another thing that we might be able to modify if we access this URI and start adding data to that record. We can see that there was an identification, and it was identified using the information that has been drawn from Pronom that is stored in Wikidata. There is a source date for that information. Scrolling down, we can see that some records don't have a reference, which is where the signature came from, but we can also see other references are available, such as Gary Kessler's file format signature table. Now, if we go back to this first record, Windows Bitmap version 2, we can see we have a permalink. Now, this tells us exactly the state of the record as it was as we downloaded it today. We can visit that and have a look at that. The record looks like any other Wikidata record. We can see here the signature, and we can see that its encoding is a Pronom internal signature, and that it was stated in Pronom on the 8th of August 2017. If we want more information about that QID, we can use Roy's inspect function. And here we have the output. Roy goes through the build process once more, and then it uses that build process to output the inspect data that we're interested in. Here we see the linting messages have been turned off, but we see an instruction about how to turn that on if we're running the process for ourselves. And here is the information we have about Windows Bitmap version 2. We can see the sources include Pronom Wikidata and Pronom Official. We can see the title is the QID itself, the revision number of the record from which we downloaded. That helps us construct a permalink, which allows us to access the record we've previously just seen on Wikidata. And then we see the history for that record, so that we can see the last 5 activities on that record and who did them. We can see how the signature is constructed. And we can see that took 1 minute 48 to output. Future work for this project involves releasing the audit trail components, which you've just seen in the demo. We want to improve the signature development workflow. That includes improving the consistency of data in Wikidata, so we're looking at you for that. Multi-part signatures need to be dealt with, where there isn't enough encapsulation between sets of signatures from different sources that need to be used independently of each other. There isn't enough instruction in Wikidata to say, use this signature or this signature. Tooling. Any tooling we can create to make life easier for yourselves, for ourselves, for the Wikidata community. Container format identification. We know that's a big one. It's one of the last pieces of Pronom and Droid that we can't imitate. And we've had a lot of discussions around the modeling. We just have to start sharing that with the community now, and we have to figure out a way of actually doing it. It might also include digital part objects, which Jack has been talking about in another session. And there's an OPF presentation later in the year, and I invite you all to come if you can. It's going to be a lot of fun. There's going to be a lot of room, time and space to demo. There's going to be a lot of space to take questions and have discussions around what's next for this work. Concluding remarks. Collaboration. The collaboration in this project was very deliberate. It was very quantified. It was cross-institution, cross-borders, and across circumstances. For those in the audience, we hope this paper provides more information about the effort involved in such initiatives. For those with a project purse, you can see the amount of investment needed, how to value this type of collaboration, and see how more and continuous investment is needed to take this work further. To help perhaps some of you to keep in mind other potential shapes of collaborative work. To help in future to identify new ways of making funding, time, or space available to develop community solutions like this. Also see how it can also be an organic collaboration with concrete positive outcomes with enough drive and determination from the team involved. The data in this project is no longer dormant. It's not a filing cabinet locked away in an office. It's actually actionable. It tells a program how to interact with and return information about the files on your computer. It is open to all communities, not just ours. It is entirely community governed, and part of that community can be us if we choose to. There's access to new tooling, like discussion boards, ways of modeling that we might not have engaged with previously. This is linked data linked to the file system. Graphs are one of the most organic data structures available to us. They're extensible and give us the freedom to express items in as much or as little detail as we desire. A graph extended to the file system with your individual records becoming a new node. Identifier plus MIME type plus file format plus metadata, taking you back out to the web. At the end of this talk, please do think about connection and the types of collaboration that you might be able to empower, how you value the work of other projects out there, the JHOVs, the FFM providers. Please engage with Siegfried if you don't already. Look at Wikidata and contribute to the signature effort. And think about new mechanisms. While we solve the container issue with Siegfried and Wikidata, it doesn't have to be done in exactly the same way as it's done with Droid and Pronom. It can be done in many different ways, and we can start thinking about new ways of doing identification. But also look at Wikidata for Wikidata's sake and all of the facts tangential to digital preservation, GLAM, and archives. Finally, stay tuned as always. There's always more work that can come out of this. But first, please give us your questions, and thank you kindly for your engagement.